So for the recording, hi everybody, my name is Ingo Müller. I'm the head TA of this lecture, and today I'm going to do an interactive SQL session with you guys. The idea is that we run interactive queries on a screen that I share in order to give you an additional perspective to the static queries that you've seen on the slides in the lecture. I really encourage everybody to be as interactive as possible. Unmute your microphones if that's okay. I guess that this won't be too chaotic. To the contrary, I hope that I get your input. I hope that I can answer your question. And I actually hope that we will uncover a few misunderstandings that there may have been very naturally. So I do hope that we will get that we will make a few mistakes together and learn from these mistakes. Let me start sharing my screen from the slides from last time. Professor Zhang has already set up this GitHub repository and a scenario on Katacoda. When you click on this link, you will get to this Katacoda tutorial. Everything that you need for that is a reason enough browser. And you can run through some of the queries that we provide interactively. If I don't know how much you've tried this already, but essentially we already provide a few commands that you need to run in this sort of virtual machine or environment, and eventually you get to. Sorry, one thing I probably stepped over something here. And so if you run these commands here, you will soon get to a point where you have a SQL prompt and you can start running queries. That's something that you can do at home after the session. So I think that now, no. Once you've run all of the commands, you get to a session where you can start running SQL queries, like here. Today, I propose that you don't do this while I'm running the sessions on my screen. I propose that everybody concentrates on this one screen and we work on the queries together on that screen. However, whatever changes I will do to the scenario now live during the session, I will also make these changes to the Katacoda environment and upload them this evening. So let me now share a different screen. And to answer the question from the chat, there is a sample data. There will be a sample database in the scenario once I do the changes this evening. So essentially what I have done before the session is set up a database server. I installed a different client, which has a bit nicer screen, as you will see in a second. And basically, we can start running queries now. Can everybody see the screen? I guess you'll interrupt me if you don't. Let me also show the chat next to my screen. Okay, great. So before we actually start, let me make a quick poll. Maybe everybody can write in the chat window, what is the experience that you have in SQL? Maybe write one sentence if you've used it in some private project. If you've only known it through the lecture, that's great. Then tell me briefly how much of that you have understood. How do you describe your knowledge of SQL? 6 of 10, none. 1 to 2 weeks in a job. Okay, that's something, I guess. Many say none from the lecture. A few private projects, web projects, a bigger personal project. That's nice. In high school even. Had 4 years of DB already. That's quite a bit. Rudimentary knowledge is also fine. From the lecture, I guess that's the case for most of you. In Gymnasium, I didn't know that that was taught today. That's good news. MongoDB still haunts me. Okay, my condolences. No few queries from high school. Okay, so we have a few. Does access count? Yes, why not? that's some experience. So we have a few experience already, but I guess that many of you know SQL from the lecture, and those are really the people that we want to target today. We want to start writing some very simple queries and make them more complex over time, and just see what happens. I hope that you can learn from how I interact with this with the shell to do something similar at home when you're working on the exercises. So let me start by copy and pasting one command just to get started from the scenario. Okay, so I have created a table here now, and let me give you an interesting command that in order to find this out. This is something that isn't related to SQL, but to the Postgres shell. If I type \, I get a list of commands that are available. And one of the commands that I will use now is a bit more down, this one. A command for listing tables, and that's \dt. We will try that now, \dt. And here's indeed the table that I just created. Now, who can tell me, how can I find the content of this table? The most basic query, select from depth table, yes. Select star from, sorry, actually, this is the correct answer. I just I actually created the wrong table. This isn't the one that I wanted to create. Sorry about that. But I mean, the principle is the same. I will just create a new query now. And we can say select from and then the table name. And here we see the current content of our table. Now, how can let's start inserting things. Does anybody remember how that works? So SQL, if you know, stands for structured query language. And there originally was even a structured English query language, if I'm not mistaken. So if you want to insert something, you actually need to type insert. And people have found it out. We say insert and then give the, the table that we want. And let's say we want to add an employee. And now we can start inventing some employee. Let's choose employee number 1. Some birth date. Okay, I actually already did this a bit earlier. Let's say that, I'm not sure whether this is true, but let's say that Professor Chung is young and was born in 1990, and he is obviously male, and I don't know when he was hired, but maybe in 2016. Okay. Now let's look again into our table, and here it is. Now, if you look a bit into the create table statement, you see that some of these values actually have this property of saying that they can't be null. Birth date can be null, and there's a default value for gender in case we don't specify it. And we have here this primary key. So now let's test a few things that can go wrong due to how that schema is defined. What happens if I run the same insert statement again? Error, failure because primary keys aren't unique. Very well. So let's just try this. Indeed, it says duplicate key value, and that's because here this first entry is meant to be the value for emp number, employee number, which we decided to have a primary key. So now if you want to add another employee, let's add myself for the fun of it. This actually works. So we need to change that. Now let's try to break one of these not null specifications. How can we do that? There's a side discussion in the chat. Let me briefly answer this. So indeed, the terminal emulator or the SSH terminal that I'm using is more by Xterm, but that isn't what makes this autocomplete. There's a Python package called pgcli for Postgres command line interface, and that's the thing that provides this autocomplete. Write null instead of the first name. So yes, that's the answer to my question. Let's fix this first and write null here. So indeed, that produces the null constraint violation that I wanted to have. Is a valid, hence unique primary key, is a null a valid and therefore unique primary key entry? We can just try it out. Any guesses from the audience? No, that's true. So we need to make sure the database system needs to make sure that every value is unique, and null means I don't know, so it can't be sure. Okay, so now let me produce this error again with a different way. If you remember, or maybe you actually haven't seen it, but then you see a new syntax now. We can specify which of the columns we provide. So I can go and spell out. I want to provide emp number. I want to provide birth. Sorry, that didn't autocomplete. I want to provide birthday. I don't want to provide first name. I want to provide last name. I want to provide gender, and I want to provide hire date. And then I just leave out this column. So that's the same thing. I have given here a list of columns that I provide, and I've given here a list of values for them. And I haven't provided a value for first name, sorry. And therefore this didn't work. Now, instead of not providing the first name, let me not provide the birth date. And what will happen now? So this will work. Maybe you don't remember. Yes. Maybe you don't remember the schema. If you've seen birth date is specified as null, so we are allowed to insert null. Somebody asked, could you also just leave it blank instead of writing null? So I suppose that with writing null, you're not referring to writing null in my statement, because I haven't done it in this version. Can I leave the field blank instead of, so can I leave the entry in the database blank instead of writing null? And the answer is no. Blank is null represents blank. The way of saying a cell is empty is to write null into it. In the first example, here again we can try it out. And this is in fact a syntax error. We need to specify something. Now, if I also remove this comma, a different thing has a problem. There's a different problem. Now the database system doesn't know anymore which field belongs to which. Can I add an empty string? That works. And then that's a way of saying somebody doesn't have a first name. I forgot to increment this. Okay, so let's look into our database again. I can have a null birth date I can have an empty string. I just can't have no string. I can't have null for the first name. A few questions in the chat. I have Postgres and pgadmin. Is there any difference? You can run the queries that I'm showing in the same way through pgadmin, for example, or the command line client that is shipped with Postgres. But I think you won't have this nice autocomplete. And then a different question. So now you've seen me doing this annoying thing of having to change the value for ID every time. So the question is natural that somebody asked, is there a way to auto increment that? And while I don't believe that this is a standard feature, many database systems actually have it. I don't know what is this exact syntax in Postgres, but essentially you would add a property here, which is a proprietary extension that says that emp number is an auto increment field. And then it does exactly what your colleague had in mind. Let me briefly check what else I wanted to cover here.
Sorry, one question. Can you explain what varchar means? Because it's unclear to me.
Right. So we see here in the create statement that this definition of the table that we are creating consists of a number of attributes. Then the next thing is a type that we are defining, and finally additional properties such as whether it's null or not null. We can also specify single attribute primary keys. But in order to answer your question precisely, the type that we're specifying here with varchar 14 says that it's a variable number of characters, in other words, a string, where the maximum number of characters is 14. So we can't insert names that are longer than 14 characters. First names that are longer than 14 characters. Let us try this. Let me put my actions where my mouth is and invent some very long name. And indeed, this value is too long for the type character varying, which I guess is the spelled out version of varchar with 14 characters. Okay. Another question from the chat. Can we change a not null constraint after the creation of the table? Yes, I have to admit that I don't know the syntax by heart. It's based on alter table, and I'm not sure whether my autocomplete is good enough here. We can alter the table and with eventually set it to null. I don't know that syntax by heart. That's something that people do relatively rarely, and I guess that for those statements, it's okay to look them up. Right. Then, what is the single character that we have? If I omit the var for variable, I actually specify that we have a fixed number of characters, and that's what we do for gender. We don't restrict what characters we mean. It would make sense to allow
das nicht von dem Type null ist, dass man dann immer was reinschreiben muss. Verstehst du das?
Okay.
Sorry, I had it.
Das war irgendwie komplizierter. Oh, right, it's that.
Somebody accidentally unmuted themselves.
Okay.
Can you mute yourself again? Thanks. So with the chat on the chat, I forgot a bit what the question was. Character also has to have a length. Yes. If we want to specify that we have a fixed amount of characters, we obviously need to define how many they are. And here for some new entry, we can test this. Too long for a single character, but we can add any one character. Okay. Great. So where did I want it to get at? Okay, so with inserts, we've seen a couple of things. While we insert, a few constraints are enforced, constraints on types, constraints on nullability, and primary key constraints. But apparently I haven't answered all of the questions yet. So that's a very advanced topic. Somebody answers essentially asks how characters are counted, whether this is characters or UTF or bytes. And to be honest, I don't know. And I also believe that this depends on the system and probably how you configure the system. The keyword to look for here is collation. I know that for you can configure the collation in many database systems, and probably things change depending on the collation. I don't know how UTF characters are counted. Can I make specific constraints like int can only between 10 or 20? Maybe the age shouldn't be more than 200 and shouldn't be negative. That's an interesting constraint. And you will see this in 2 weeks in the lecture and a few weeks later in the exercises in the context of integrity constraints. In a bit, we will see another interesting integrity constraints. Say we have a different table, which we will create in a second, that refers to employee numbers. We want to enforce that that other table can only use employee numbers that actually exist. That's called a foreign key. We haven't seen that yet, but you will see it in 2 weeks also. Okay, so let's start querying this table in a bit more fancy way. One thing that the most simple thing that I may want to do is select only a subset of these columns. How do I do that? And I'll just start with this. No, wait a second. I wanted to discuss something else, which I think is interesting. We have seen this. We have seen this syntax, which I used in order to not specify one of the attributes. But can somebody speculate? Can somebody speculate what could be another reason why we want this syntax, which seemingly looks more cumbersome? After all, we need to specify these attributes here. So even though this syntax is longer than the other one, why could this one be useful? You can unmute yourself or write into the chat. I have there are a few already. Yes, Lucas said, if I only want to insert 5 of 100 and all of the others are nullable, then this is essentially what I did. That's a very good point. User input might not be complete. I guess that's similar. We omit some of the attributes. But we have two other ones. The order of the attributes could change. That's indeed true. And I add a variant to this use case. It could be that the schema is extended, as in we want, somebody may add columns, which are optional fields. And in order to make this backward compatibility work, so no, we can write queries that survive these schema changes. With this syntax, if somebody either changes the order of the columns or adds new ones, the query will still work. If I use the earlier syntax, the query would break. And in both cases. So this is a good reason. And I guess that if you aren't in front of a shell like we are now, but you're writing an application, it's a good practice to use the more verbal syntax. In that context, there's another benefit. It somehow documents what the query does and makes itself explanatory. I can understand from the query itself what the different fields mean. Okay, back to the previous question. How can we now start selecting? Essentially, the question is, how can we express a projection in SQL? if you're quick enough, maybe just write the query in the chat window or unmute yourself and go ahead, shout it into the room. Right, so instead of star, which essentially just means all attributes, I can say which attributes I want. I can just say the select the employee number, and here the autocomplete is indeed interesting. I can add a few more. Now, what else? What do you think? Will this work? Yes or no? No? I think it does. Guess it works. Maybe what? Maybe. Okay. It indeed does. We can select attributes a couple of times. This may lead to problems down the road. If I'm quick enough, we will get there. We will see an example. A good question from Philip. Why does this work? So even at the risk of jumping over things, you've maybe seen that we can use union of two subqueries, where in each of the two subqueries we would write select something from employees and something else from, I don't know, clients. And let's say that okay, I can't make a good example that makes sense in the real world. But let's say the schemas are different, and I want to. Okay, no, I need to discuss. Yeah, no. Let's say the schemas are different. Then this union will not work if I just select star on both sides. And it could be that the way to make the schemas the same. That there is a way that makes sense to make the schema the same, such as selecting the first name and last name. And for whatever reason, let's say that here is let's say here we use last name because here we want to say username. Okay, it could be something like it. There could be an example like that, where for whatever reason we want to have 2 times the same column, and union could be one example. Does this answer the question, I guess? Okay, now a few other questions. Don't keys need to be unique? Now this is, let me try to answer this question. I think that here's a confusion of 2 concepts. One is a key makes sure that in the table, different rows, values of different rows can only occur once. But first, here, what isn't unique isn't a row, it's a column. And second, this may not even be true. There are no keys in queries that I write. I can do something like this. If I just select the table as is, the values here are still unique. If I start computing stuff from them, such as computing something modulo 2, you see that it's not unique anymore. And I can do something confusing. I can call this again. I can specify an alias, as in I can give this new column a name. And now we appear to have an employee number column with non-unique values, but in fact, the relation that we are seeing now isn't the employees relation. It's some relation produced by this query. So the keys don't hold. And then schema columns are unique, but again only only in base tables, only in relations that I create. I can't create. I indeed can't. I can't do this. Oops. Oops. Sorry. I can't have two employee number fields here. But that doesn't hold for queries. In queries, having two columns is possible. This may lead to problems down the road. For example, if later I want to refer to this field, I will have the problem of needing to disambiguate which of the two I want to refer to. Now, this is another interesting thing. Somebody pointed out union all or something is bad. Let me point this out. Let me show this example again. This is a good reminder of the fact that SQL is running on bags and not on sets like the relational algebra that we've seen. You see here how even though we only have a single column, different values, some values occur several times. In other words, the records in this relation aren't unique, and that's because SQL runs on bags and not on sets, as relational algebra does. Who knows how I can make this these values unique? Say I want to remove all duplicates. How can I do that? Right, select distinct. You remember that? That's good. Essentially, with select distinct, we can get the behavior of relational algebra. If we omit it, which is the default, then we have bag semantics. Now, we've seen already a couple of things that I wanted to show you here with the select. Let me show you a few other examples. So we have seen how we can give new names, like this one. What? Last first, my mind did two things at the same time. So I can, no. I can specify aliases, as you've seen. I can change the order of the columns. I can do computations. You've seen the modulo one. There's another way, a few other possible things. There are string operations like this string concatenation operator, and I specify a string literal of a blank in order to produce the full name. This is a relatively specific functionality that you typically look up. So these string operations, you don't need to know them by heart. For the date column, such as birth date, we have an interesting feature in order to calculate automatically what is the difference in time from that date until today. And with this duration, so while birth date was a date, age will compute the duration, and there's another what we can do with durations, for example, is extract components such as the year. Should be from. So we can extract the year component of this duration. This is just to show you that there is a whole lot of functionality for different data types, such as strings and dates, but also geometric objects and many other things, which we don't need to cover in detail. That's something that you can look up when you need them. What happens if you type select distinct first last name? Which of the two, what will be made distinct? That's an interesting question. So, no. Let me elaborate that question. So we see how we added a couple of Müllers. So if we do distinct last name now, this will eliminate all of the Müllers but one. However, if we have first name here, what happens? We see that Müller appears several times. Now, I guess while this answers the question, I really want to, I want you to understand why. Can somebody speculate? Why does this not eliminate the duplicates? And let me show you that this way it also doesn't happen. Why doesn't this eliminate the duplicates of Müllers? The whole row has to be unique, yes. So that's the semantics, we found that out. The tuples must now be distinct, not the single last name, the whole tuple, yes. So I guess that this explains the fact that it is like that. Think a bit about the possible semantics of the alternative. Let's say we wanted to exclude all duplicates of Müller. What value would we have here? Would we have only Ingo Müller? Would we have only Müller without first name? Would we only have Hans Müller? Who would we have? And there is no good answer. So I guess that what I'm getting at is that the semantics of the alternative isn't sound. So the only possible thing that this can mean is to make the whole tuple distinct. I'm not 100% sure whether that was actually the reason that the standard committee made this decision, but for me this is a good explanation, which I guess you can remember more easily just than this binary number of this binary value, it's one or the other. Is relation the same thing as a tuple? It can be that we sometimes use one for the other, but that's abusing language. So with relation, we normally mean the entire table or the entire relation, whereas a tuple is one row in it. Okay, we had another question. Does string concatenation work with other types? I think that this may also be not fully standardized. So the question is, does something like this work? And apparently it does. And so what's happening behind the scenes is that the number 42 here is automatically cast to a type that can be concatenated. Where this is a bit more obvious why we want this to work is maybe birth date, which can be converted to a string and then concatenated to the literal. Okay. In the tutorial, there's now a small section of using select statements in order to produce inserts. But I think I will jump over this a bit. Or no, let me make it very quick. Let me copy one other relation that we have. So we can start producing more interesting joins. All right. So let me do these inserts until 3. Then we can have a break and continue with something else. So basically, what I want to do now. Let's go back to showing the tables. I want to start using different tables. Until now, we have used only the employees table. I just now created the department table, and very early, I accidentally created this one already. Let me insert a few departments and then get to where I was getting at. No, this won't work. Insert into departments values. Yes, why not? Sales, marketing, and development, just to have a few. Let me show it to you. Select star from departments. So I just added these three cells. And now let me do the following, just to show you that this is possible. Let me try to create. Let me try to populate this dept.emp department based on the employees that we have. Now, what the intention here is that employee number contains a value of that was used for employee number for one of the employees. Department number is a value of one of those. And then we have a from date and to date, which specifies the range, the date range in which this employee worked for that department. So what I want to do now is to create a query that says that every employee that we have now is currently working in the development department. So let me just write this query. Since we're basing ourselves on employees, I start with this one. Now I want to create a table with this schema. I want to have the employee number. I want to have the department number, and let's say that everybody at the moment works in the development. Interesting, in the development department, and they are working since maybe 2000, the 1st of January of last year until today. So I can produce this relation that for each employee contains an entry where, okay, maybe let me put aliases just to make it, sorry, as to date, as from date, just to show my intentions, and as department number. So with this query, I can produce a possible content for this relation. And now there's this interesting functionality where I can say insert into and then a relation followed by a select statement that produces a result with the same schema. And that just works. That does what hopefully you think it does. It inserts the result of this query into the relation that we've given. Okay, then let me just do the same again, just for fun, and say that before last year, in the year before that, 2019, it's from date to 2000. So from 2019, from the 1st of January of 2019 until the 1st of January 1 year later, we all worked in the marketing department. Just to have something. Insert into. Okay. And now we have, for each of the employees that we already have, we have this current entry where everybody works in the development department, and the past entries that work in the marketing department. And we will use this after the break in order to do something interesting with more than one table. Quick question about what I discussed in the last few minutes before we go for the break. Anybody?
Yes, I could ask.
Yes.
Do we do the same thing for variable department numbers and dates for the different employees? Or
right. So we could, yes, that also works. And I do something now that probably doesn't make sense, but it shows that it works. I can do something like this now. I can just take the employee number as department number, right? It does make sense, but just because I can't come up with a better example now, I guess that this qualifies as we have a variable instead of a constant, and that works. Except that for this one row where this query happened to produce an entry that already existed, but the other entries have been in fact, this whole thing failed. So that was an interesting question. Maybe very briefly, the one from Michael also, is there a way to ensure that every employee only works in one department at the same time? Not an easy one, and because this requires looking at different attributes at the same time. And anyways, the mechanisms to do something like that, even though this particular one is a bit complex, you will see it in 2 weeks together with the remaining mechanisms on integrity constraints.
I have another question.
Go ahead.
So in the first table that we looked at, there was a question mark as the default value for gender. And I was wondering, when does it insert the question mark? Like, if we leave it blank, does it just automatically insert the question mark, or what does that mean exactly?
Exactly. So your speculation was correct. In the columns that are marked as nullable, if we don't specify a value, then null becomes the value that is inserted. In those that have a default value, that default value gets inserted. Let's see, but I can very quickly demonstrate that. I need the longer syntax. So let me remove gender and insert some Thomas Müller and not provide this value. And here the default value was chosen. Okay, before we don't get a break, I propose to leave it at that. And let's resume at 3:15. If you have unanswered questions, I can answer them then. Okay. So see you at 4:15. Okay, so welcome back. Let's continue. I hope you had a good break. My plan for now is to start with the 3 tables that we produced just before the break. Let's have a quick look at them again. Remember, this command dt is a Postgres command that allows us to show us the tables that exist. And let us just peek at those again. An interesting command, if you don't know it yet, is to limit the amount of lines that are shown using the limit clause. So let's just show an individual line of each of the tables. So just as a reminder, we briefly mentioned it earlier, this table here in the middle, the department employee table, is there to connect the employees from this relation with the departments in that relation. Roughly, I would say that employees and departments are entities, and this relation stores a relation. I'm using relation here with 2 different meanings. So this table stores the relationship between employees and departments. Right. Good comment from Alessandro. This limit is actually a proprietary addition. There are other dialects of SQL. Microsoft SQL comes to mind, where the same would be expressed like this. And this isn't particularly interesting for the lecture. We'll only use Postgres. If we use programming, if we do programming questions in the exam, you will also need Progress. But just, you know, for the back of your head, there are alternative syntaxes in other systems. Okay, so the idea, coming back to my tables, the idea here is that the employee number in that dept-emp relation refers to employee numbers in employee relation, and the department number in the dept-emp relation refers to the corresponding values in the department's relation. Now, who remembers this from the lecture? How can I in any way combine these three tables? When I say select star from employees, how can I do something similar with more than one of these relations? We can use joins, natural joins. Yes, that's correct. That's what we want to look at now. Kreuzprodukt or cross product, correct? Or cross join, how it's called in SQL. Cartesian product is also another name. That's also correct. Somebody says we should use the where clause. Yes, but that's not all. We need to have a way how to specify which tables we want. Right. So we have a first suggestion that I think will work. We can, instead of saying from employees, we can just have a list of tables. So we can specify here dept-emp and departments. And the proposition was to use where the attributes are equal. So apart from, sorry, let me try to deactivate. Okay, that's good enough. The autocompletion for the query that I ran earlier. So what do I need to do now? Where the attributes are equal. You probably have the right thing in mind. Can somebody spell it out a bit, in particular for your colleagues who maybe haven't seen it yet? What exactly do we need to do here? So basically, we need to express as a condition the thing that I described in natural language earlier. We want the rows where the department number here and the department number here match. Now, in fact, let me go a step back. Yes, Michael already makes the right proposition, but let me go one step back, such that everybody can imagine a bit better in their heads why this pattern works. So if I don't add anywhere if I don't specify any where clause, what happens? What if I run the query like this? Right. We get the cross product of the three. That is, we get any combination of these three. And now let's see whether we can detect it. Yeah, so we see here all of those share the values from the attributes that come from the employees relation. And then we get I guess that this looks like the different values of the employee of the emp-dep relation that repeat here. Let me scroll to the right. I have to say that yes, and then no. So those are all of the different entries from the dept-emp relation. No, I'm not sure whether I completely understand where these values come. No, I do. So for each entry, for each row here, this is the first row in the employees relation. All rows in the emp-dept relation are repeated. That is, all combinations are produced. Then for the second row of the, then for the second row of the employee relation, all of the other ones are produced. And if we look at the very right, those of the department relation are all the same. If we scroll down enough until we've seen all combinations of all rows from the first two relations, we see how finally the second row is also combined. Long story short, this is the very large cross product of the two. So we have all combinations. Now, why does this pattern that your colleague suggested make sense? We have all of the, until here without any condition, we get all of the combinations of these three tables, but we're actually only interested in the ones where employee number matches between the two relations and department number matches between two. And now here my autocomplete is already pretty clever, and it tells me that probably I want to express a condition with the department number of, and I want to say that it is the same as my relationship relation. It's not as clever as you guys probably are. So what I want to express here is that the department number from the departments relation should match the department number from that debt emp relation, and similarly for the employee number. So why does it not autocomplete now? Employees emp number should be the same as debt emp employee number. Okay, so now let's see. Who can explain what we are looking at now? For example, Professor Zhang, why is he here 2 times? Who can explain this? Bag semantics? That isn't the answer, but it will lead, but verifying that it isn't will lead us to the right answer. So let's see. In fact, this row and this row, they aren't even duplicates. They are different here in the from date and the to date, among other things. They're also different here. He's employed in department 1 and department 2. Yes, that's true. Now, semantically, this may not make sense, although it's not as bad actually, because if we look at this relation, remember we created these entries, each for one employee in the department 1 until today, and in a different department for a different a different time. So the answer to my question, why do some employees here occur several times, is because those are the combinations that exist. In fact, here the combinations are the combinations involve every employee twice. And this row produces one row in the result with Professor Che, and this one as well. That's what the simple answer to my question is, because that's what we specify the query to do. Now let's look at something else. We added this employee where we didn't enter the birth date. This poor Thomas Müller doesn't show up in our query at all. You see employee number 6 doesn't occur, and that's because no combination exists where there's a row here with employment number 6 with a matching employment number here. Okay, so I hope that you believe me now that this is a sensible combination of these three relations. If not, now is a good moment to ask. I can walk through the query again. Is there built-in for natural join? Yes, there is, and we will see it in a second. I want to show you a few other things before. Now, one one thing that we have seen earlier is that here we can use aliases for columns. We can actually also do that for tables, and that's something that we will do, which is a good idea to do for more complicated queries. That's called employees just E, dept emp as DE, and departments as D. And now our query become a bit shorter. And since we only have 3 relations, I guess that these shortcuts are still understandable enough. That produces the same result, but it's a bit shorter. Now, let's start with, maybe one more thing to make this a bit more readable again, and tie into something that we've discussed earlier. You see how employment number is repeated here, the same as department number is repeated here. You can probably imagine where this comes from. One of the two is from the employees relation, and this one or department relation respectively, and this one is from the dept emp relation. We can get rid of it by specifying projections. For example, we can only say I want employment number, first name, last name, department, to date, from date. I don't know why this is quoted. Let's ignore it. Right. Okay. This is a great example. This wasn't an intended mistake, but it's actually a great mistake. We have a problem here now, and that's something that we discussed earlier could happen if a particular query produces columns with the same name, and we want to refer to that name, which here for doing the projection we do. We need to disambiguate. We need to say whether we want this employer number or this one. And in this case, it doesn't actually matter because we had a condition that the two should be the same. But that isn't necessarily the case, so we need to specify it. And I just pick any here, except that I need to pick one that actually exists. Okay, so now we have our join. I'm not sure I understand, but we kind of need two deployment numbers. Right. So let me rephrase the question, and if I don't get it right, you intervene. You're saying that if we pick only one here, then how can we refer to this one and this one? We need to make the distinction between this one and this one. How does selecting one of the two not preclude that we still have two? And in a way that the answer is that the where clause isn't aware of the select clause yet. Exactly. Somebody guessed it. The select is happening after where. This is something that you may criticize from SQL. It's not always, and the order in which you write the clauses is not necessarily, and it's often not. It's in fact often not the order in which things are executed, and it's not even the order in which. It's probably not even the order in which you need to think. And a very early attempt or a very early goal of SQL was to sound like natural language. And in English, it so happens that you say, I want to select, I don't know, the apple from the basket. And that's how this order came about. It's not, from the semantic point of view, you have to think that where is executed before select. And I guess that's a good explanation of why this isn't a problem. Okay, now let's go back to the question that your colleague had about the natural joins, and let me reformat this. This command, this shell, this actually has a nice feature that you can use several lines, and I'm going to use this feature now. So this is, while this is a way to express the join, it isn't the only way, and I'd argue that isn't the best way. We'll explore another one now. Instead of saying that we want the Cartesian product, but then only a subset, we can directly say that we want a natural join, and the way how it works is like this. Oops. Natural join, and then that amp and natural join departments. And yes, and now suddenly we don't need any of these conditions anymore. Let us convince ourselves that this is actually the case. We're testing here that department number of the two relations should be the same. So that's what natural join does. So if natural join in SQL maybe it doesn't do exactly, but what the join in relational algebra does, but it has the following in common. It matches, it joins on the attributes that are in common on both sides. So department number is in common between departments and dept amp, and deployment number is in common between the other two. So the natural join essentially automatically expresses this condition. And I forgot to DE to specify the aliases as before. So this does the same thing. Right. So Michael made a suggestion to have a SQL alternative that is called SQL, that is spelled like the English word SQL. That's a good idea, but you're not the first to have it. Actually, SQL was called SQL the way how you propose to spell it. But that was already the second system. So there was some name ownership issue, and they were forced to rename it to SQL. Interesting idea though. So back to the to our queries. Do we need to specify the aliases? Let's quickly find this out by seeing what happens if we project everything. Does somebody want to speculate what happens if I do this? We don't need the aliases. In the beginning, we also didn't need it. We can just spell out the. Actually, we don't ever need it. We can always spell out the names, right? I guess that the question is, do the duplicated attributes still appear? So who wants to speculate? We get the columns only once. Is one guess. They still appear. Let's see who's right. They actually don't. I have to say that I wasn't sure about that either. Good that we didn't bet for money. Okay, so but let's talk about the natural join. The reason why I don't remember this is because I claim that using the natural join isn't a particularly good idea. Can somebody speculate why I may have come to this conclusion? Yeah, we have a few guesses here, and they all point to the same thing. The same argument as for insert, dependent on the relation definition, only works for columns with the same name. Yes, it's true. It doesn't always work. The names must exactly match what if that isn't the case. Now it can be, and those were the first two guesses, which are correct. It can be that the query does exactly what I want now. But let's say some funny developer wants to remember when a department was created and adds the birth date attribute to the department, what will happen with our natural join? Well, because birth date for the employees has the same name as the birth date of the departments, the values from these two columns also need to match. And suddenly our join does something completely different and something completely meaningless. So using natural joins, in my opinion, is a way to ask for trouble. At some point, things in the schema may change and the queries will break without you immediately noticing. There is a middle ground. There are join variants that don't involve the Cartesian product and the where condition, and that are the natural join. Does somebody know one of them? Inner join, yes. Join on, I guess that they both end up at the same thing. So yes, let's try those out. Instead of saying natural join, we can say inner join or just join, which is actually the same, and specify a condition here. And here again, my auto complete is clever. It knows which is the relation that I'm joining on, and there's one attribute in common, so that's probably the one that I want to join on. So I can, instead of specifying the condition in the where clause, I can specify it here. So let's just mix these two. And verify that it actually still does the same. So why would we prefer this one to the Cartesian product with the where clause? As one or otherwise, as one of your colleagues says, on works just like where. And that is true at least to a first approximation. And some people now speculate that the one that we're looking at here now is better because it's faster, because it uses less memory. And this is actually not the answer that I'm after. It's more flexible because the query engine can do the join. It can see that we want to do a join and therefore do optimizations. So all of these are valid guesses, but you have forgotten one thing that we have I have to admit, we have mentioned it, but we have mentioned it very briefly. We will see it a bit later in the lecture. We've very briefly said that SQL is a declarative language. What you will see at least in the second half, probably in the last third, is what a query does when you send it to when you presented the query like this. And in fact, what it does, let me say what it doesn't do. It doesn't execute it in this order. It also doesn't execute it in the order that has the right semantics. It understands what you want. It understands what you declared you wanted, and then figures out a way how to execute this efficiently. In particular, if you say you want a cross product, but then you specify an equality condition on these two input tables, every sensible system on this planet understands that this means a join and will execute a join. So the answer is clearly not we prefer this over the Cartesian product because in the latter case, the system executes the Cartesian product. It doesn't. There may be toy database systems where this isn't actually the case. Anything that anybody can ever recommend to you to use it will execute a join. So this isn't the answer. If this isn't very clear yet how the database system does that, that's okay. We haven't seen it in the lecture yet, but I guess that you should begin to understand that something is happening. after you write the query and before the database system executes it. Okay, let's see what other. And we have another question. Why use the inner join first and then the join? Actually, that's another thing that the database system decides for you in which order to do the joins. Most likely, or it isn't necessary the order in which you specify them. The database system makes a decision itself based on what it thinks will be faster to execute. More declarative for the user. Maybe that's the right thing. So let's look at the inner join doesn't use column names implicitly. So the inner join is better than the natural join, but that isn't the question that I'm after. Let me try to show the two at the same time. I guess that this was the old one. So okay, this isn't particularly fair, but I guess that you understand where I'm getting at. Which of these two formulations? This one or this one? Do you think it's easier to see what happens? I'll answer the other questions after that. Somebody said the one with the join, and maybe that's because you understand that that's why I'm getting at. And obviously this is a somewhat subjective answer, but there is a benefit of saying join some condition, because a reader sees that you probably specified this condition in order to do a join. So yes, that's a good way of phrasing it. First, join is this join and the natural join are both syntactic sugars for the cross product with the condition. There are different ways of declaring the same thing to the database system. So the reason why you would want to pick this one over this one is because a different human reader or the same human that has written the query sometime later will probably find it easier to understand what the intention of the query writer was in this form rather than in this form. So let me try to answer a few questions. Could we also use the join twice? So I used here I used here one time inner join and the other one join. In fact, the keyword inner here is in a way again to document, or because there's an outer join, which I don't want to go into details here. Omitting the default join is an inner join, so saying inner join is the same as saying join. Okay, we can remove it, and the semantics are exactly the same. Yes, and the remaining discussion in the chat is all correct. Why do we get different results again? Here we get a different result here because we get a different result here than here because here I had the list of, because here I also specified a projection. We get the same result here and here. So whether I say join on or Cartesian product with where condition, that's the same. Actually, I never showed it, but I can. Oops, what? An empty select, interesting. Right. So I guess that answers this question. We don't get the same result. I'm sorry for the confusion. Sorry, we don't get different results. We get the same result. Sorry for the confusion. Right. I hope that I clarified this. Now, there's yet another variant, and I'll just show it to you. We have this variant that says join on. For this case where I do want to specify what to join on in order to protect against this change of semantics if the schemas change, I can also say using, and then specify the column name or column names that the two sides have in common. And that's again syntactic sugar for, sorry, let me make this disappear. Yes. So this is syntactic sugar for that. And I think that that's a valid way to phrase it. And I guess that we can ask ourselves the same question as before. Is the field repeated? And I also don't know for sure. Using employer number. Is the employer number field repeated? So it's not exactly equivalent. The difference being what are the projected columns, but I guess you can still classify that under syntactic sugar. Okay, and maybe now let me add one thing to the query in order to show why this is maybe a good idea. So let's say we only want the current employees. Those are the current assignments of employees to department. Those are the ones where to date is in the future, or at least today. So I'm not 100% sure whether this will work actually. Okay, let's say where to date is after or the same as, and now I'll write out the date of today. It also doesn't matter too much what the condition is, but let's say I want to select only those based on to date and not those. So my advertisement argument of using one of these join variants rather than the cross product is that conditions that aren't a join are separated from the conditions that are a join. And I guess that's just another example of rephrasing of what I said earlier. Okay, questions about the joins? Have I answered everything in the chat? Yes, so you all made good explanation of why one join is maybe preferable to the other. So I guess that there isn't much to talk about. So, okay, other joins. What about half joins? Does that semi joins? Right. So the semi join. I guess that there are two ways to specify this. Let's make this example. There is a way how you can do a semi-join without using any construct that we haven't seen before. Remember how employee 6 doesn't show up here. So if we select now the employees, if we want to select only the employees that are employed in some department, in particular, we don't want this one, then we could do this with a semi-join. And one way how to do this is to do the normal join that on, using imp number. And this is still a normal join, but I can do this. And this may be Postgres syntax, or it may not be supported. But I can just make a projection to all of the attributes of employees. And okay, I'm happy to see that Postgres does support the syntax. I can just project to all of the attributes in employees, and that's I guess that's your semi-join. If that relation.star syntax isn't supported, then I still have the possibility of enumerating all of them. Melina, I'll get to your question in a second. Let me still show an alternative. You've seen this in the lecture actually. Select star from employees. I can do a where clause, and for example use exists and a nested clause. I can now in this parenthesis write another query whose result will be used by the where clause, and essentially exist returns true whenever there is some entry in the result of that nested clause, and otherwise it will return false. So I can say here select star from dept-emp where dept-emp dot emp number is the same as employees dot emp number. Right. Okay, I actually see that I did no. Let me first explain what's happening here, and then correct the mistake that I did here. So what we're seeing here is this nested query, and semantically you can think that this nested query is executed for each row in employees. So I can use the attributes from employees in that nested queries. The semantics are that we should run this query for every employee, and the employment number of the outer query is sort of a constant in the context of the inner query. So for every employee, we run this query and we check whether each employee's employer number exists in the dept-emp relation. Does that make sense? Okay, there's a right. There are a few other ways to express this, like basically every time in SQL, but that's one way of expressing a semi-join. What isn't the way to express a semi-join is what I said earlier, and I can explain why this is wrong. I'm not sure what I can explain why I even thought that it's correct. It isn't correct because in this join we will get an entry for every record. We will get a result row for every input row in the dept-emp relation that has a match. So I'm not sure what I thought, but this doesn't do what I wanted. Okay, so I guess that the person who asked how do the semi-join is happy. Whatever confusion I created with this answer, please ignore it. I'm sorry about the confusion. What does a semi-join do then? So the semi-join, as we've seen it in the lecture in the context of relational algebra, is to rule out rows that don't exist in some other relation, but don't take into account the don't use the attributes from that relation. Yes. Otherwise put, how one of the colleagues says, the semi-join is essentially a join and projection. It's just not the join that I came up with earlier. But because there were questions about the nested query, let me try to explain this again. We see the whole query here. Let's now isolate the inner query and see what it does. If we use the whole inner query, it actually doesn't work because because this employees relation doesn't exist in our query. What we can do though is use an individual constant, say employee number 4, and that will produce something. Employee number, sorry, I meant 5, I said 4, and we can use it for 4, we can use it for 3, etc. So when we use this query that we ran now with a couple of constant as a nested query, you can think, and that's correct for the semantics. You can imagine that this nested query is executed once for every row in the outer context, with the attributes referring to the outer context being constants. So it is as if I rendered subquery for this line with 1 as this constant. Then I run it for this line with 2 for this constant. I run it for this line with 3 as this constant, etc. And this is again syntactic sugar. In reality, the database system doesn't run 5 queries or 5 million queries if we had a larger data set. It will do something more clever, but you essentially shouldn't worry about that. And you should only think about the semantics, and the semantics are this subquery is executed for each row in the outer context. Is that a better explanation than the previous one? Does that explain the question? Okay. Very briefly, is join left associative? And I think that hasn't been asked already, but because I'm not 100% sure of my answer, I skip this one. If it's important to you, ask it in the forum and I'll answer it there. Is the subquery executed once per tuple of the main query? In terms of semantics, yes. And for the purpose of today, we don't need to go any further. You will see in the last third of the course that the database system does something that's called query optimization. And among other things, what it does is to unnest correlated subqueries, but that doesn't need to be a concern to you for the moment. Is there a more efficient way to do this? Yes, there is, but we don't have time to explain it. Very roughly, you can also express that as a join. And finally, an organizational question: will recordings be uploaded? Yes, like always. There will probably be a small delay until I can access the files, but then we will upload it in the usual place. Okay. Any other questions that are very urgent to you now? So at some point later today, I will upload what we've seen today as a Katacoda tutorial, so you can look at it again and then ask questions either about the things that I said or about the other things in the tutorial. in the forum, and we happily answer them there. There don't seem to be any urgent questions now anymore, so we can call it a day. I hope that you found this interactive session interesting. Friday will be pretty similar, except that Thomas will do the session instead of me. I hope that this gives you two different perspectives, how two different people approach these kind of things, and therefore maybe you can learn a few new techniques. Okay, thanks everybody, and have a nice day, everybody.